put on this computer. So the first thing I'll do is go through that assignment that we've all had to. So we'll go do
Can
the
you
assignment.
give me 1 second? I just have to find my notebook.
Go ahead, Rita. Go ahead. Go ahead. Go ahead. By the time we get all set up here, you probably have enough time to.
Yeah, I'm ready.
I'm ready. And see, I'm not even ready yet. You see, so told you you'd be faster than me. That's because you're much younger than I am. Okay, so I hope you guys tried the assignment because this is a typical way, best way to get prepared for the test. And so now here, what I'm basically asking you to do is, of course, if you have a 24 kilonewton force, I should do this. Okay, if I have a 24 kilonewton force here and a 24 kilonewton force here, well, you first have to make sure that your lumber is strong enough to be able to resist that force. And then on top of that, once you've chosen the right lumber size, then of course you have to make sure that your nailing is sufficient to be able to transfer the force from one member to the other. So here I say determine the size of the lumber and the number of nails, the length of the splice to result. Okay, now use 4-inch nails, and I did this purposely, the 4-inch nails, because I don't know if you guys took advantage of this, but I did this purposely so that we can, take advantage of the fact that we are much longer, and we can take advantage of the clinching and therefore help reduce the number of nails. So first we need to determine, I'm telling you, use SPF number 3 size lumber. And the irony is that what you actually need is probably not even available, but that's another story. Use the spacing below because, like I said, I'm going to start you off in this way. I don't want to have to correct 18 different exams or 18 different problems. I'm going to sort of give you the N distance, the A distance, and so on. And of course, the number of rows I want you to use. So here we go. Now, so the first thing we're going to do is, of course, find the size of the lumber. Okay. So we need to so first of all, we are in SPF. Okay. So we are in SPF. Okay. And of course, we are in number 3. So we're somewhere in here. Okay. So the first thing I look for is a TR value that's greater than my TF. And of course, there is the, okay. So the irony is that you probably have a harder time finding an SPF 38 by 184, in other words, a 2 by 8 in a number 3 than you would finding it in a number 2. Okay, just to let you know. So this is the irony of it all. So anyways, this is the grade I told you to use, and this is the species. So therefore, you have no choice but to say, well, it's a 38 by 184. And therefore, that means that if you can't find a number 3 and you only find number 1, number 2, don't worry, it's even much better. So your TR, as long as your TR is good in your TF, you're good to go. So there's your size of lumber. Okay. Now, if, for example, you knew that you would have, if you would have a series of these splices, you have at least 3 members that have all the same splice, and you have sort of a load sharing, and if this was like part of a truss or whatever, then of course you can take advantage of, oops, sorry. Okay, so you can take advantage of that case 1 system, but if this is just one splice, then you have to take it as being a single member, and that's it. Now, so now we have our TR is greater than our TF. Great. Now, what we need to do is, of course, this is our famous equation to calculate the resistance that we get, and of course, this is the resistance times the, depending on the penetration, depending on the number of shear planes, depending on this is the number of nails. That's what you're trying to calculate. Your K prime and the JF. And of course, I'll go through this again one more time. So first thing we worry about, okay, is we look at the NR prime NS. And of course, I don't have to worry about the side plates are made with lumber. Okay, and I don't have to worry about minimum penetration. I will go straight away to side plates made of lumber. It's 38. I have a 4-inch nail here. So, and there's the diameter of the nail. That's something you should keep in mind, okay? And therefore, the maximum penetration for an SPF is 38 millimeters, and therefore, like if you look at what you're doing, this is your splice here that you're splicing together, and of course, you are going through 38 here, okay, and you're going through 38 there. So therefore, you know that you can take advantage of the NR prime NS therefore this is going to be equal to 1.19 kilonewtons per nail. And of course, you only have one single shear, so therefore you don't even, NS is going to be equal to 1. And remember, this is where you get the diameter of the nail, because you might need this information later on. So that's where I get the value. I don't worry about the minimum. So because I'm not, I have 38 and 38, not a problem. I mean, I do have, if the minimum, if I want to look at the minimum for 4-inch nail, the minimum penetration is 24. I have 38. So the minimum is 38, the maximum is 38, and therefore I don't have to worry about this value here. And of course, if you're putting a plank, guys, like this, if like if a plank is 19 millimeters, okay, and then you had like a 2 by something, okay, and you're putting a 4-inch nail through there, well, then you'd have to worry about it, because then you're not going through the minimum, and therefore you would have to somehow adjust your value here. So that's the thing about. So that's it. So now from there, I go back, and I know that I have 1.19 kilonewtons per nail. Okay, and of course I only have one shear plane. This is the number of shear planes. I only have one. Now the modification factors. Now, the K prime is the combination of your KD, your KSF, and your KT. Okay. And of course, if we go back to this slide, KD, of course, is a standard load. I didn't say it was anything special. It's a dry and non-treated, so 111, and therefore we know that our K prime would end up being 1. Okay, but it's good, guys, to go back and to jog your memory, like just in case, for example, if we had a different type of load duration, then we would have to modify it. If we had a different service condition, we'd have to modify it. If it was treated wood, we have to modify it. But it's always good back to remember what you're doing here. Now for the JF, of course, it's JE, JA, JB, JD. Okay, now when we go back to the same slide here, so this is 1.0 when the nails are used in the side grain. And of course, when you're splicing two pieces together like this, okay, one is there and the other one is there. And of course, that's okay. So you are nailing into the side grain. So therefore, we have a value of 1, okay? The only time you worry about the end grain is, like I said, when you have a bottom plate and you have your stud or your and you're nailing you're nailing into the end grain of that member. So that's when you have end grain. Otherwise, most of the time you're always nailing into the side grain of your wood. Now JA, nails not used as toenails, and of course we're not toenailing anything, but if we were toenailing, we would have to reduce our resistance down to 0.83. So therefore we still have a value of 1 here. Now 1.0 for unclinched in single shear, okay, and nails in multiple shears. So therefore, we are looking at a single shear situation. Now, can I take advantage of this? Okay. In other words, can I take advantage of one? In other words, I can increase all my resistance by 60% if I can take advantage of this, and then I'll show you how you can do that. Now, the clinched portion of the nail should be at least 3 nail diameters long. Okay, so we'll check that, and of course, we are not in a shear wall or anything, therefore the JD is 1. So the only variable here that I can maybe take advantage of is the JB for clinching. I don't know where they put B for clinching. I guess bending, I don't know. I have no idea. Okay, so here I can understand where they put the E for end grained and then the J for, I don't know, for angled. I guess they put A for the angled nails, and I don't know where they use B for maybe B for bending the nail, I don't know, and D for duration. I have no idea how they came up with those subscripts. Okay, so here we go. So therefore I have 1 for the side grain. It's not being toenail. Now, like I said, when the nail is in single shear, and of course, if you look at our problem, we have one single shear. In other words, the nail is being driven here. Okay. Now, is this amount here long enough so that when I clinch it, it can consider to be clinched? And of course, the clinched portion of the nail should be at least 3 nail diameters long. Okay, so that's what you need. So if it's less than 3 diameters long, then you can't consider it to be clinched. If it is, then you can clinch it. And if you remember that when you're clinching it, you should actually twist the nail with the claw and then bang it back into the wood. That's the proper way of clinching. So here we go. So a 4-inch nail, of course, a 1 inch is 25.4 millimeters. I multiply that by 4. That's the total length of the nail. Okay. The diameter, we got that from the table, 4.88. Okay. And I told you that's a good piece of information to retain from the table. And of course, now I have 102. So in other words, this is 38 and 38. How much is left here? So 102 minus 76. Okay. I have 26 and I divided by the diameter. I have 5.3 diameters that extend. I need only at least three nail diameters. So therefore I know I can clinch. Okay. Or you could do the other way. Like you take 4.88 multiplied by 3. And if this length is longer than 4.88, what's 4.88 times 3? 4.88 times 3. So in other words, if what exceeds here, okay, if I take 3 times the diameter, okay, which is 3 times 4.88, and that from on my calculator I have 14.64, but let's say 15 millimeters. So if this ladle is longer than 15 millimeters, yes it is, it comes out 26 millimeters. Okay, I can clinch it, therefore I can take advantage of JB equal to 1.6. I don't know if any of you take advantage of that, but that's what you could have done. Okay. And now I got a JB of 1.6, and therefore that's going to help me into significantly reduce the number of nails I need. And of course, I'm not in a shear wall. That's 1. So all of a sudden, I take all these factors, and I end up with a JF of 1.6. Now I can go ahead and calculate the number of nails since I have all the variables in here. And of course, this is what we got from the table. This is what we just got from, modifying the modification factors. And of course, that stays to 1. And all of a sudden I'm at 12.6 nails. Now, if you didn't take advantage of the JB, you would get an answer of 24 divided by 1.19. You ended up with 20 nails as opposed to 13 nails. So you added 7 more nails because you didn't take advantage of the fact that you could have clinched the 4-inch nail. And now, okay, so I'm going to be using 13 nails. And of course, I gave you the pattern. So I mean, this is 3, 5, 8, 10, 13, sufficient. Therefore, the end distance is 60, the end distance is 60, the spacing between in other words, if you remember, when you go look at the table, okay, I'm sorry, when you go look at the table for the spacing, this is the end distance, this is the A value, this is the A value, and then of course here you got to make sure you respect the C value, and trust me, on a 2x8 you will respect the C value and so on. And then of course you need to have the end distance. And if I'm not mistaken, for an SPF, I believe this was 13, this was 39, this was 26, if I remember correctly. So that's good. Therefore, the total length of the splice that I'll need is 280 millimeters, which is pretty good. So does anybody have any questions? Did everybody realize that they could have taken advantage of the value of JB equal to 1.6?
No,
Pardon?
not me.
You didn't, right? So you ended up with 20 nails, right?
Well, I actually did other stuff, so I had to redo this assignment.
Oh, okay. Well, anyways, look, like I
Yeah,
said,
so I got 21 nails.
yeah, because
I
you didn't take advantage of JB. You understand? You know what I mean? So keep that, like I threw this at you so that like you realize that by reviewing this stuff, did anybody take advantage of JB equal to 1.6? That's what I'm curious to know. I don't think so, right? So anyways, so keep that in mind, guys. Like that's why it's good to go through that checklist, okay, and see, if you have to do something before you go ahead and just, work everything out. Because the checklist will, for the K prime, it's a good reminder. For example, if I don't have a standard load, and if I don't have, as a matter of fact, when it comes to today we're going to learn how to like Formwork. Well, Formwork is basically just you'll see it's very repetitious of what we learned in terms of bearing walls, in terms of joists and all that. But I just want to, I don't want you to have these guys, you know, like just see that, oh, I could only design joists for floors. No, you can design joists for anything. It doesn't matter whether it's being applied for formwork, whatever. I just want to broaden your scope of design is design. All you have to be able to do is assess your loads. And if you can do your geometry, you can apply it to anything. So here you go. So that's it. Does anybody have any questions before I close this PowerPoint?
Yeah, I have a question. I just don't really understand what this, like this sketch with the crosses, it means that the nail is coming from the other side?
Yeah, like in other words, like whenever you want to show, whenever you want to tell the guy that you want to put the head on this side and the point on the other side, okay? So like what you do is you simply, you know, and I should have specified this, like, you know, like what if I was doing this in real life, I would put, okay, nail, I would write this on my sketch, nail near side, okay? In other words, this would be with the head on this side, and the X would be nail far side, okay? And I would specify it so that they'd understand what the graphic is. So the guy would put the head on this side, would put the head on the other side, put the head on this side, you understand? And then, so that's all that means. Is that, in other words, you don't want to have all the clinching on one side. You want to have, you know, about half the heads on one side and half on the other side. That's all that means, okay?
Okay, thank you.
Okay. So, okay, so that's what that graphically, I should have specified that that's what it means, but I think I showed you that last week, and that's why I didn't bother showing it here. But if you were doing a sketch, yeah, you should specify what these graphics represent. You don't take it for granted. And okay, near side and far side. Okay. So if that's it, we will, this should be it. So therefore we can end the show. Yeah. I'm having a hard time hearing it. I'm sorry.
I think someone's mic is unmuted.
Oh, unmuted. Okay. So that, because I thought they were trying to talk to me and it sounded like they're talking to me at the end of a tunnel or something. Okay. So let me close this. So we don't have to, I'm not going to stop sharing. Okay. Now, as far as, okay, like I said, I'm just going to show you, you know, like once you learned how to design wood, whether you want to build a balcony, whether you want to build a floor, whether you want to build a store with it, whatever it is, doesn't make a difference. You know, like the design procedure is all the same. And of course, one of the more popular places that wood is used is when it comes to formwork, okay? And I'm going to show you, like, you know, how you would apply it and what the only modifications you would do when you would be applying it to formwork. And of course, so now, first of all, we all know what formwork is, right? Or should I have brought up 18 different pictures?
No,
I think we know what it is.
I'm good. Yeah, thank you. I think that reassures me. Thank you. Okay. But anyways, if somebody says, well, what's formwork? Well, here's a definition of formwork. Okay. Formwork is concrete construction referring to the assembly required to give a desired shape to a structural or architectural element. Okay. So if you want to tell somebody is you're basically creating the mold that you're going to be pouring the concrete in so that when you remove the mold, it's going to end up having the shape that you want it to have before, you know, so that's what it is. You're basically creating a mold, right? So that's formwork. It's, you know, creating a mold. And of course, so now, what are the materials that are most commonly used in formwork? Of course, like exterior Douglas plywood, you know, like Douglas fir plywood, DPF, okay, is one of the more popular ones. And you can also have Canadian softwood plywood. So any plywood, okay, any plywood would be okay. There's even some plywoods that are like companies that make special plywoods that have a very treated surface so that it's super smooth, so that when you want to have some very architecturally exposed form work, in other words, you want to have the minimum amount of defects in the experiences of the removal of the formwork. The companies that, and if ever you want to use their plywood, well, they will have tables of what load that their product can actually hold. Okay, now this is something I don't know if you guys learned this in any of your construction classes, but whenever you're using plywood, okay, even if you're using the treated surfaces, okay, you should always have what we call a release agent. In other words, this is just a spray that you spray on the surface. It's an oil basically, okay? And you spray it on the surface, and what it does is that it doesn't allow the water to kind of like go into the wood, and therefore it adheres. Like once it actually cures, it will adhere to the surface, and then when you try to rip it off, you get all kinds of defects. So what this agent does is basically separates and make sure that the concrete stays just sitting right on top of it, and it acts like a barrier. So I don't know if you guys have ever seen that, but it's basically just an oil that they spray on the surface of the panels. And that's something that if you want to get a smoother surface and you want to have less problems removing the panels because it hasn't actually been, attached or adhered to the concrete once it's dried, these things are really, really what you should be doing, okay? So concrete contractors that do this, they know that, and they'll definitely, like this also applies for walls as well as for slabs. If you just want to make sure that the concrete does not, adhere to the things. I don't know, you guys have probably learned about Duraforms, where anyways, now OSB, oriented strand boards, for reasons of economy, are sometimes used in applications where forms cannot be retrieved after concrete has been poured, okay? So there's situations where, for example, there are situations where you are, let me just give you an example, okay? Well, I'll give you an example. I don't know if you guys have you guys ever driven on the Ville Marie Expressway, the 720 downtown? Okay, when they built the Ville Marie Expressway, what happened was that they were making what we call a box girder bridge. Okay, and what they did is that when they put the plywood, when they put the plywood to make this, and it was going to stay closed, they used OSB board because it was going to stay there and they weren't going to retrieve it. Okay, so whenever you have this, for example, if you're going to put some plywood here and you won't be able to retrieve it once the forms want to be removed, well, whenever you want to let the wood just stay, and for economic reasons, you don't want to use plywood, you want to use something cheaper to do the paneling, you can use your OSB board. But I can tell you right now, you better make sure that this is an area that when the OSB board starts to deteriorate and starts to smell up the place, it doesn't create another problem, okay? So just keep that in mind, that when OSB starts to deteriorate, it can give off an awful stench. So if you want to save some money, okay, and then 2-3 years on the road, people that have this like around their house and it starts smelling, where does that smell come from? Well, that's probably the OSB that's deteriorating, that hasn't been removed from the formwork, okay? So that's, they say.
Can you give us an example of like where we can find like something like that, or when they
well,
do
it's
that?
like, for example, like let's say that, okay, here, I'll give you an example. Okay, you have an excavated surface here. This is a vertical. Okay, you have an excavated surface, right? And for some reason, it's very irregular. Okay, and you don't want to be able to lose all that concrete in this vertical surface here. Okay, so the carpenters are going to be it'll be very easy for them to put up the formwork on one side here. Okay, it'll be very easy for them to put the formwork here, but then once the concrete is poured, it'll be impossible to go and retrieve that formwork. So they'll just leave it there for life. Understand?
Okay, I see.
You get it? Okay.
Yeah.
So to put it up is not a problem, because you got nothing in your way. You put up your studs, you put up your OSB board, you put your tie rods, and then it's after you poured your concrete. How the hell do you get it out of there? There's no room for a worker to go down there and cut the tie rods and start removing the. So it just gets like, they just probably try to remove the top portion here as much as they can, and then leave everything buried in the ground. You understand? So that's what they mean, like when you know that you won't be able to retrieve it because there's not the space. But for example, if I'm building a regular wall, right? Well, in that case, if I know that the plywood is here and the plywood's here, and I have ample room to go for the workers to go and work here, then I will use plywood. But whenever I have a space constraint because of then I will use OSB board and leave it just sitting in the ground. And instead of wasting money for plywood, I'll use OSB board. You understand? So that's one example. Okay. So there is now loading. Okay. Now we learned this is just, like I said, if whenever you're going to be using, paneling, use plywood, don't use OSB. Now loading. Now, if ever you're actually designing formwork, okay, these are the standards that you should, if you ever get into, guys, formwork for high rises have to be designed and approved by an engineer. And that's whether it's the walls, the shoring, okay, and before they actually pour the concrete, the engineer has to sign off that the formwork meets his design. Okay, so the guys that get involved in designing formwork, these are the standards that they would have on their shelves to make sure that they meet all the requirements. And this is okay. These are just for vertical loads. In other words, whenever you are, these are for. So you have two standards for vertical loads. Okay, and for horizontal loads, you have another standard. In other words, when you're designing walls, okay? So if you're designing the formwork for walls, okay, like how much pressure gets exerted when you dump the concrete and all that, well, you go to this standard here and it's going to tell you, well, when the concrete drops from this height, this is the pressure you should be using to design your formwork, okay? So that's what this standard does, okay? So this is for lateral loads. So for walls, you would use this one, and for vertical loads, okay? In other words, when you're designing a slab, you should be using these CSA standards. So if you get into formwork, keep in mind that these are the standards that you'd have to pick up, okay? Now, if ever you're doing, like we're going to be doing something very simple. So all I did is I want you to realize what you can do here. Okay, for residential, you don't have to worry about it. It's not that serious. And I'll show you what you'd have to include here in terms of vertical loads, which some people would overlook when they're designing their formwork, okay? So now, when it comes to design, of course, okay, in the calculation of the factor loading, the weight of the concrete shall be taken as a live load. So the first thing you have to worry about is that up to now, we've been designing everything, concrete was dead load. But when it comes to formwork, concrete is no longer a dead load, concrete is a live load. So in other words, the load factor goes from 1.25 up to 1.5, okay? So that's one thing. So your concrete, that's what you have to think of. Oh, it's a live load, not a dead load, okay? So that's one thing that, the first thing you have to realize, okay? So in other words, usually, like when you look at your different load combination, you have 1.45D plus 1.5 L, right? So normally concrete always goes in here when you're calculating the self weight of the member, blah, blah, blah. Yeah, but when you're doing formwork, well, it goes here. This is the load factor you use for your concrete, okay? So that's number one. That's what you get out of the standard, okay? Now, so in other words, the load durations. Here you can take advantage of the fact that within 7 days, I don't know if you guys remember this from your concrete mix class, but within 7 days, concrete usually attains about 70% of its strength and it starts supporting itself, okay? So that means that it no longer exerts a load onto the formwork, and therefore you can consider it to be a short-term load. So therefore, whenever you're designing for formwork, you can take advantage of your KD now of 1.15, and we will take advantage of that, okay? So this is what they mean by 7 days or less. Why? Because, like if you remember your concrete curve, you understand, it was like you look at it and then all of a sudden, like at about 7 days, it had reached about 70% of its strength, and at 70% of the strength, it can actually support its self weight, and therefore it's no longer loading the formwork. So that's why we're allowed to consider it to be a short-term load. And the other thing is that if all of a sudden I have a series of joists, okay, I have a series of joists, okay, and I'm putting my plywood and I have at least 3 joists and they're at most 24 inches apart maximum, and you never go that far for formwork, number one, okay, but and also you can take advantage of the fact that you have a load sharing, and therefore you can take you take advantage of the KH equal to 1.1 because you have at least 3 joists spaced no longer more than 24 inches apart or 610 millimeters and are generally parallel to each other. Now the reason why you don't take case number 2, even though I'm putting plywood, is because nobody's going to nail the plywood like you would nail a floor. In other words, at every 150 millimeters along the edges and 300 millimeters at the intermediate ones, because you need this nailing requirement in order for it to be considered a case 2. So that's why we'll never consider, even though I have sheeting, because we don't nail it, because it would be horrendous trying to strip the formwork after that, and nobody does that. So you never take the case 2 values for the joist. You always take the case 1 if you have at least 3. And I think I even put it here to remind you, okay? Never use systems case 2 values for the joist due to the nailing requirements for case 2, okay? And if you guys don't know what the case 2 nailing requirements are, well, after today, I mean, you'll probably never know for the rest of your life. And if ever if ever you need to go back and re-jog your memory, go back to the second lecture and read what's on the PowerPoint to remember what the nailing requirement is. So that's for case 2. Now the plywood formwork selection table provides specific design pressures to satisfy. Okay, so I'm going to give you a table, okay, that already gives you what's the pressure. In other words, what's the load in kPa or in kPa, because we're doing it in metric, okay, based on the orientation of the plywood, based on the spacing of your supporting members, okay. What the table can actually tell you, what thickness you need in order to satisfy the load that you're imposing on the plywood, okay. So therefore, this table already accounts for the MR value bigger than the MF value. That's already calculated for you. And also the VRP value, this is for the panel, the shear panel, because it's slightly, okay, the planar shear capacity is greater than the VF value. So this is already built into the tables. And of course, there's also deflection criteria, okay, when it comes to formwork. In other words, do you want it to be L over 270 or do you want it to be L over 360? So usually if you want to have a very nice straight surface and not having too many undulations, you're going to go for L over 360 and so on and so on. I don't know if you guys notice it, but there's more and more high-rise condos, even high-end condos, okay? It's becoming very, very popular. If it's made out of reinforced concrete, they try to leave as much of the reinforced concrete structure exposed in the condo. That adds like another feature to the condos. I don't know if you guys know that, but that's, it's been a trend for over 10 years now. So that's why, like, when in terms of deflection, you have to make sure that you want to keep the deflection so that the surfaces are nice, stay nice and straight, and so on, okay? Like I said, so the tables will already take all these 3 design criteria into consideration. And therefore, all you need to know is a couple of the variables that. So here, this is the table. Okay. So this is okay. Now COFI, okay, is Council of Forest Industries. Okay, so in other words, this is the council that's been set up in order that governs how plywood is made and so on and so on. Okay, so this is the Council of Forest Industry, and this is Form Plus. Okay, so if they certify that the plywood is considered to be Form Plus, well, then you can use this table here to decide what thickness of plywood you need to be able to support the pressures that the concrete is going to be imposing on the plywood. So the way that this thing works is very simple, okay, is number 1, okay, is face grain orientation. Now, I hope you guys realize even plywood, okay, which is 4 feet by 8 feet, the grain is always in a certain orientation, okay? So whenever they make plywood, like if you look at plywood in cross section, okay, the outer faces, okay, the grain is always parallel to the length. So if this is 8 feet, they'll always put the outer layers of the plywood parallel to the length. And when they say that the face of the grain is perpendicular, so for example, if these are my supporting members for my plywood, like this, that means I'm going to be installing the plywood in this direction. Okay, and if it's installed in that direction, then I can use these values. Now, this is when I want to get a deflection of L over 260. If I want to place it perpendicular, I want to get a deflection of L over 270, sorry, 360. Well, I would be using this table here. Now, if you're not sure, in which direction the guy's going to, like normally the guys by according to the rules of the good trade, they will always place the plywood perpendicular to the supports. But if ever for some reason they can't do it, well, then you're no longer here. You're going to be more conservative and you can go and use the values down here. okay? So for if all of a sudden here are my supporting members, okay? And all of a sudden this is the grain of the plywood, well, all of a sudden I fall down here because the plywood is not as stiff when the grains are running parallel as versus running perpendicular. And that's why they have two different tables. So for example, if I take, for example, the same spacing of my supporting members, okay? And if I take, for example, the same deflection criteria, okay? Look at this. This one can hold up to 172 kPa, and this one can only hold up to 91 kPa. So it is significantly weaker in the other direction, okay? And now, so this is, for example, when it comes to plywood, when it comes to formwork, you don't have to worry about 300, 600, 400, in other words, 12 inches, okay? You can space your members at 4 inches, 6 inches, 8 inches, 12 inches, 16 inches, okay? 20, I wouldn't go to this one, okay? So in other words, it's up to you. I can even space them at 225 if I want, you understand? Because it's just a temporary structure. So if I need to space them at 200 for whatever reason, I'll tell the guys to space them at 200, okay? So this is one thing about plywood. You don't have to worry about that standard, 8, 12, 16, 24. In other words, 300, 400, 600 spacing, which is the standard spacing for the paneling. You can, go anywhere from as low as 4 inches, 6 inches, 8 inches, 12 inches, 16 inches, 24 inches, okay? So these are, very, very, acceptable spacing because it's a very temporary structure. So that's how, so in other words, once I've decided what's going to be the spacing of my supporting members, now they can be like, basically these are my supporting members, okay? And remember, whether it's a slab, for example, if I'm pouring a slab, here's my plywood here, okay? And all of a sudden, here's my supporting member, okay? And I know the spacing of my supporting member, and that's my slab. Well, I can tell you that once I know that, I can come to this table depending on my deflection criteria, and I know the spacing of my supporting members. I can tell you like what would be the amount of pressure. And of course, what you have to keep in mind here is that these are the specified pressures. These are unfactored. So in other words, when I calculate my loads and I estimate my loads, and I get like, for example, 9.5 kPa, well, that's what these are. These are unfactored loads, number one, okay? And keep in mind that whether the plywood is being subjected to this pressure or if I'm building a wall here like this, okay, and I have, for example, I put my studs here and my studs are spaced at every 24 inches, okay? It also applies if the load is being applied like that, okay? And of course, so it doesn't matter which way the load is applied. This tells me that when I'm building the formwork for a wall, if I space them at every 24 inches, and all of a sudden I can calculate the pressure created by the concrete down here when it drops by 2.5 meters and all that, and I can calculate that pressure. Well, I can come here and see, well, if I want to, what thickness of plywood I would need to be able to resist that pressure. And of course, as the plywood gets thicker, okay, now keep in mind that guys that do formwork, okay, what they do is for example, they buy, they will buy a 3/4 inch plywood, okay, 3/4 inch plywood, and that's what they'll use all the time, okay? So therefore for them, so for example, if you know that you have a pressure that a 1/2 inch plywood would be okay, and you see the forming contractor using 3/4, don't even break your head. Then it'll be way more than what you need. But you want to make sure that you can at least, he's using the minimum that's required in order for the loads that you are designing the formwork for, okay? And if you want to remember, okay, if you want to remember right down here on the table, oops, sorry, I shouldn't have done that. Okay, that's, I apologize. Like, so here, because I have this thing in the way here, it says design pressure is a specified loading, not the factor loading. So therefore, you don't factor your loads and you come to the table, whatever specified loads that you've estimated, that's what you come and use the table for, okay? Well, now I'm gonna have to do this because okay, so there, oh, what's this? Last viewed, there we go, okay. So we're gonna come back, of course, we're gonna, any example, we're gonna come back and use a table. Now, here is, for example, a situation where I want to pour a slab, okay? and they've designed the slab, and they came up with a slab thickness here of 225 millimeters. Okay, and they want to make sure that when they pour this formwork, they don't interfere with the vehicles, going back and forth, and therefore they literally want to be able to span these joists. Okay, they want to be able to span these joists, so therefore that they can put up the formwork here. In other words, they can put up this bearing wall here, okay, made out of 2x4s. And then after that, they can put the joists and they can put the plywood. And this way, as they're working up here, and then as this plywood needs 7 days to cure, and by the time they finish it, if they need to have the traffic go by, they're like creating a bridge. You understand? So this would be, otherwise, if this wasn't the requirement, then they would simply put a lot of shoring here in between and make these very, very close together. So if ever you need to have some, so it's just like designing a floor, okay, that is sitting on 2 bearing walls. So these are 2 bearing walls. This is like a floor joist. And the only difference is that my concrete is not a dead load. My concrete is a live load, and I have to start designing what the loads are. So I have to design what the thickness of plywood I need and what the size of the joist I need. And then I have to determine at what spacing will I put my 2x4s so that it can support everything, okay? So so here I have a span of 3.6 meters. Okay, I have a height of 3.6 meters, which is, starts getting pretty high, okay? So it allows the vehicles to go underneath your formwork. And now what we're going to do is learn on how to design this. Now, believe it or not, you've got all the know-how based on what we learned on how to design floor joists and how to design bearing walls to be able to solve this problem, okay? So it's just going to be more of a reminder or a refresher what we're doing here today, and nothing new. Okay, the only thing that's new is how we're going to calculate the loads. And there's one other thing that you're not aware of, and that's what I'm going to talk about today. Okay, so right now for figure number 1, okay, determine the thickness of the plywood. Use coffee plus form plus plywood. Okay, the plywood will be placed perpendicular to the supports, which makes sense, okay? And the deflection is limited to L over 360. So this way, when you go to the table, you can see what's the minimum thickness plywood you need. Now, keep in mind that here, I'm already telling you that the joists are gonna be spaced at every 300. Now, if that doesn't work, then you could go down to 200. And if 200 doesn't work, you can go down to 100, you understand? So I'm starting at 300, and if this works, then so be it. And if it doesn't work, well, I'll put them together. So right now, I'm as a preliminary spacing, I will space them at every 300. And that's going to tell me what I'm going to, and then of course the studs as a preliminary spacing, I'm going to space them at every 600. So I want to see if that works. And if it doesn't, well, I'll tweak my spacing so I can eventually get the joists that I can use, or the spacing of the stud that I can use in order to finalize my design. So now, okay, now first thing I need to do, this is something that is, okay, whenever you are designing formwork, remember, workers are going to be on your form, placing the forms, placing the reinforcing steel, placing the concrete and everything else. That's called a walking load, okay? Now, if you're doing something that is industrial, okay, or you're doing something that's civil, like for example, if I would be designing the formwork for a highway, okay, this is the walking load that I'm required to put down, 3.12 kPa. Okay, so that's the minimum walking load I should be putting down. Okay, so that in other words, when the guys are pouring a formwork and all of a sudden they dump a big bunch of concrete there and they have the guys working around there, well, this walking load should compensate for, like that, all that load that's happening right there on your formwork structure. Okay. So this is a walking load. Now, if ever you're doing something residential and it's only going to be you and your dad that's going to be standing on the formwork when you're doing the, you're placing the concrete, and you're not going to, you're going to be placing it very accurately and you're going to be screening it right away. Well, you can go, you don't have to use this. When I'm doing for myself, whenever I'm doing residential, if I use 1.0 kPa for my walking load for residential, I find that that's sufficient, okay? In other words, 20 pounds per square foot is a reasonable walking load, but if you're doing something more important, like an overpass or whatever else, then you should be using 3.2, okay? So that's your walking load, and that's one of the loads that you have to keep in mind, okay? Then after that, what do you have? Of course, you have the weight of the concrete itself, okay? Now, determine the size of lumber and the bearing length. Use SPF number 1, number 2 lumber, okay? Because we're going to be using joists to create the bridge, okay? We're going to be using joists to span across those bearing length. Now, determine if the bearing walls can be made of 38 by 89 SPF number 3 stud grade for the spacing showed. If not, what should be the spacing of the studs? Blocking is to be provided at every 1/3 of the stud height. So what we're going to be doing when we get to the bearing load, we will know that as far as the B dimension goes, we will be laterally supporting at 1/3 the height. So we'll be modifying the length of LB, but LB is going to stay the whole length of the stud. Now, so load on the plywood. So we start with the load on the plywood. Well, we have the weight of the concrete is the unit weight of the concrete times the thickness of the slab is going to give me how much the concrete weighs, right? So therefore, I end up with 23.6 kilonewtons per cubic meter. And what's the thickness of my slab? 0.225 meters. And that gives me that eventually the concrete is going to be giving me 5.3 kPa pressure on my structure, on my plywood, and then of course on my joists and everything else. So that's the weight of the concrete. Now, of course, I can't forget that at the same time people are walking while they're placing the concrete, so therefore I have to have my walking load, you know, simultaneously as I'm placing my concrete. Therefore, the total load that I'm going to be placing on my formwork is going to be 8.5 kPa, okay? Now, so that's going to be the live load, okay? So now, if I go back to slide 13, okay, so this is my service load, 8.5 kPa. If I go back to the table here, okay, we said that we wanted to have a deflection of L over 360. We said that we're going to be putting the plywood parallel, okay, we're going to be putting plywood parallel to our supporting members, in other words, our joists. So therefore, we are here, perpendicular to this, perpendicular to the support, and we said we're going to be putting a spacing of 300. So if I come here and I look at just the very thinnest plywood that I have, which is 1/2 inch, this will be able to support a pressure of 25 kPa. So therefore, if the contractor uses 1/2 inch plywood or greater, it's okay. So the minimum plywood I would expect, and nobody uses less than 1/2 inch plywood to do formwork anyways. So if the contractor has 1/2 inch plywood and that's what he's going to be installing on top to create the formwork for the slab, as far as I'm concerned, that's okay. So therefore, it's greater than what I have. And that's how I choose my plywood, just to make sure that I reassure myself that clear all drawing. So last viewed. So therefore, I go for a design pressure on a 1/2 inch plywood is 25 kPa. All I need is to have a pressure of 8.5 kPa. That will be ample for the load on the plywood. Now the next thing I worry about, I'm going down. So right now I'm at my plywood here, and I've decided that here's my concrete. Here's the people walking on my concrete, okay? And all of a sudden I have my joists, okay? So basically what I need to do is I need to calculate the dead load of my formwork. In other words, I have to make an allowance for my plywood, okay? And make an allowance for my joists so I can calculate the dead load of my structure. Okay, so, and then once I have the dead load, as far as the live load goes, well, that's what was imposed on the plywood. Okay, so now the joist design, the dead load, I'm not gonna start worrying about like 1/2 inch plywood weighs about 0.7 kPa. I'm gonna round these up to 2 pounds per square foot. Like I'm designing, I'm going to try to facilitate and make sure that I account for more. As far as the joist goes, I'm going to assume that they're 2x12s at every and I'm going to make an allowance of 4 pounds per square foot for the joist, so I won't have to break my head. And therefore, I will use a dead. I'm not going to be like, I'm not worrying about being very, very precise on my dead load. This is a very temporary structure, so if I slightly overestimate my dead load, so be it. I don't want to underestimate it, but if I slightly overestimate it, I don't care. I'll only be that much safer. So if all of a sudden there's a bigger mound of concrete, well, hopefully I'll be able to account for that. So there's my dead load. Okay, so I don't go into the, I just want to make a reasonable allowance for my joist, a reasonable allowance for my plywood, because if I go into those tables, I probably end up here with 0.07 kPa. Here I end up with something like 0.14, 0.16 kPa. And is it going to make that much of a difference at the end of the day? No. Okay, so for the time that I'm saving here, I'm going to be slightly overestimating my dead load. And if I need to go back and tweak it, I'll tweak it. But for now, I'm going to overestimate my dead load. And of course, my live load is my concrete and my walking load. Now, of course, I'm designing joists. Well, whether it's joists for formwork or whether it's joists for floors, I have to factor my loads. Okay. So therefore, I'm going to, just like we did, now I'm just going to go straight to case 2 because I know that case 1 doesn't govern here because my live load is not, my dead load is going to be definitely much smaller than my live load. So I go straight to load combination 2 and I factor my load. So 1.25 times my dead load. And like I said, the big mistake people make is they add the concrete here and that's wrong. So therefore, keep in mind that the concrete now becomes part of your live load, not your dead load. And it's only your plywood and your joists that are the dead load. So that's going to be my factored load. And when I add this all up together, I end up with a factor load of 13.1 kPa. Now I have to be careful here because this is what I'm going to use to design my joists. And this is what I'm going to be using to design my bearing wall. So I got to be very careful that I've done this properly. So now, what is WF? Well, just like we did with floor joists, the factor load times my tributary width, we decided to say we're going to start with the spacing at every 300 millimeters. So therefore, what's the tributary width? Well, of course, it's a joist spacing. This becomes my tributary width, and therefore I multiply my factor load by my tributary width of 0.3 meters, and that's going to give you my WF. So 0.3, and therefore I end up with 3.93 kilonewtons per meter. Great. So now I've got what I want. I've got a support there. I've got a support there. I've got a span 3.6 meters. And I've got a WF. Wow. So what can I calculate? I can calculate my MF and I can calculate my VF. So now I can get the strength of my joist. Now, the next thing I want to do is that since I'm keeping the deflection here to L over 360, I want to make sure I keep the deflection here down to L over 360. So therefore, I need to calculate the live load deflection or the, so the live load times the tributary width gives me WL. And of course, that is what I'm going to be using to calculate the stiffness of my joist. Now, this is being ultra conservative because as soon as the guys walk off the formwork, well, you know that it's only going to be the concrete. So it's up to you if you want to be very conservative, use the total live load, or if you want, just use the weight of the concrete as the live load and then calculate the deflection accordingly. Okay. But I'm going to I'll be on the safe side. I'll put them both together. Now, MF, of course, WF L squared over 8, simply supported member. Okay, and what's my L is the span between the bearing walls. I end up with 6.4 kPa. And VF, of course, 7.1 kilonewtons. And of course, the ESI is one of the deflection of L over 360, and this is the deflection equation. And we go ahead and now isolate the ESI required, and we calculate the ESI required for the joist. Now, this is where you can take advantage of short-term load and of course of case 1. You cannot go to the tables and take the MR value for case 2. You will not have the nailing requirement. So what you need to do is just like we did for the problem with the joist, okay? Well, let's calculate the ESI required. Now, there's nothing to do here because it doesn't get affected by the load duration. It only gets affected by the treatment and the, wet. And of course, keep in mind, the joist will not be wet. It's only the plywood that comes into contact with the wet surface, not the wood. So it will not be wet. And therefore, just like we did, okay, we can take our MF value and divide it by our factors that are no longer just the value of 1 and reduce the MF value so that when we go to the table, we can find out what MR value we need to satisfy the MF value. And in this case, it only helps us, it doesn't hurt us because we're taking KD equal to 1.5, KH equal to 1.1. In other words, we're taking a systems 1 case factor. And therefore, it's only going to help us. And also the same thing with VR. I take the KD and the KH and the same, both exactly the same factors, okay, in this case. And now I can go to the table and look for an MF value that's at least 5.1 and a VR value that's at least 5.6. And of course the ESI value, so I have 5.1 kilonewton meter, 5.6 kilonewtons, and the ES is 569 times 10 to the 9 Newton millimeter squared. Okay, so those are the three values. And just like we did for floor joists, what do? We go to the, so we know we're here. We know we have SPF, okay? And if you remember, you don't see it here, but it says here that when you take the single members, and because I've already modified, I can go look for an M. So here, now if you notice, like if I wasn't gonna modify my MF value, I wouldn't even be able to find a value in the table, okay? So here, I can use a 38 by 286. I have an MR of 5.5. I need an MF of 5.1. I have a VR of 9.76, and I have a VF of 5.6. And I look at the deflection 740, and all I need is 590. So this meets my three design criterias. And like I said, if you weren't going to modify, you know, for the KD value, and you weren't going to modify for the KH value, because here I'm using the values for a single member, you would have said, well, the spacing is no good. I'm going to go revise my spacing. But taking advantage of the fact that you are going to be able to modify the strength of the wood because you have a load sharing system and you have a short-term load, well, you're allowed to increase the resistance accordingly. So keep that in mind. So there you go. And therefore 38 by 286 is ample. And so 38 by 286 single member. And that's, like I said, I modified it for the short term. I modified it for the case one system. And therefore 550 is greater than 541. 970 is greater than that. And the 740. So even though I kept the walking load for the, it's still stiff enough to make sure that my deflection stays well over L over 360, which is great. Now, what's the last thing I need to calculate? Like anything else, I need to calculate bearing length, okay? And of course, the same thing here. Since it's short term, I'm allowed to increase the QR value by the short term factor. Okay, so I can multiply this by 1.15. Okay, and thereby reducing the LB required. You know, so that means that I need 39 millimeters. So if I'm building a wall out of 2x4s like this, okay, this is going to be my bearing wall, and my joists are going to be sitting to the end of the wall here like this. Okay, I know this is 89, what I have. I need only 39, so I know I have sufficient bearing here. I'll have absolutely no problem if the carpenter makes sure that the joists go all the way to the back side of the wall. Okay, so this is the LB provided if the joist is built all the way to the back side of the wall. If not, the carpenter should not put it any further than 39 millimeters away from this edge. And if he does that, you're the one that'll have to check that. And that's why you need to know that. Because if you go to the job site and all of a sudden you see the guys put up their bearing walls, like they put up the bearing wall and they have the joist sitting right at the tip here, well, you're going to tell them that's a no-no. Okay. And what I would tell them to do is I would take a 2x4, nail it to each joist, and increase the bearing length there. Okay. That's how I would remedy that problem. So that's okay. So there you go. That's your LB required. Now, what we want to check now is to see if 2x4s at every 24 inches, would that be strong enough to support our wall? Okay. And of course, the bearing walls we said are made with SPF number 3 stud grade. Okay. They're 38 by 89 2x4s, and we're going to start spacing them every 300. Now, we said that the length of the wall is 3.6 meters high, 3,600 millimeters. But as far as, if I make an elevation here, so here is my, oh, I should have drawn this a little bit better. Okay, so here are my studs, like this. Okay, and of course you should have some kind of a mud plate. They call these, they call these mud plates. Okay, the ones that are sitting below, because they literally sit in the mud. That's why they call them mud plates. So you make sure you have your mud plate there. And here are my studs at every 24 inches. And of course, this is the D dimension here, like this, okay? So as far as the B goes, we are going to be putting blocking across the B like this. And we're going to split it 3 ways for the B. So what's going to happen is that the B is going to be laterally supported at every 1/3. In other words, at 1200, 1200, and 1200. That's the B dimension. In other words, in plan view, I'm only laterally supporting the B dimension, and therefore the D is the full length here. So therefore the LD is going to stay 3600, but the LB is going to go down to 1200. Okay. And that's, of course, should greatly improve the strength of our stud. So here we go. Now that was our factor load. So the factor load for the bearing wall, the same factor load that I used to calculate the load that's going down the wall. Okay, so that doesn't change. Now, if you look at plan view, okay, this is what's happening. Here's my slab. I don't care how wide it is, but I care on how long it is. Okay, so I know from here to here I have 3,600 millimeters. That's the span of my joist. My wall is sitting here, okay? And I have these studs that are spaced at every 600, okay? So what's happening is, all I need to determine is how much of that load is going down on each stud. So in other words, what's the tributary area that this stud is carrying? Well, it stands to reason that if 3,600 here, it would be 1,800 going that way, 1,800 going that way. So that's how much of the load. And then the spacing of my studs here would give me the tributary width in this direction. So this is 600 or 0.6 meters. So therefore the tributary area of each stud would be 0.6 meters times 1.8 meters, okay? And that's how I calculate my tributary area. And of course, once I know my factor load, that's going to be the PF that's going down on each stud. And of course, because you're putting your joist all the way to the back end of the wall here, you can consider this thing to be concentrically loaded, and therefore you don't have to worry about eccentricity and all that. So now, tributary area is half the span times the joist spacing. Okay, that's your tributary area. And of course, I end up with 1.08 square meters. So each joist is going to have to support an area of 1.08 square meters. And of course, how do I calculate my PF? Multiply that by my tributary area. I end up with 14.1 kilonewtons. Okay, so that's the force that the stud has to resist. Now, how much does the force can resist? Well, you're going to have to calculate it. So this is the same thing that we did for bearing walls, okay? And that's why I didn't test you on bearing walls right after we did bearing walls, because I knew I was going to test you on bearing walls in the formwork. So this is where you're going to get tested on how to design a bearing wall. Now here, like I said, is it going to be the LD or the LB that's going to govern? Well, once you determine that, then you'll know if you have to use PRD or PRB of those two equations. And we did this for bearing walls, so therefore, KELD over D, KELB over D, and the only difference here is that this is down to 1200 because I'm blocking it every 1/3 of the way. And of course, it is the biggest slenderness ratio that will govern the weakness of the column. And in this case, it is the D that governs, no longer the B. And you can appreciate that if I was going to block it, okay, and I was going to divide the 3,600 by, in other words, if I take the 3,600 and divide it by 38, I would end up with slenderness of 94.7. That would be totally wrong because the maximum slenderness ratio I can have in wood has to be less than or equal to 50. So that would be totally wrong to start off with. Okay, so that's why you need to block it or you need to support it laterally. So that's what I'm going to be using. I'm going to be using, now, since it's the D that governs, I'm going to, like, if you remember, we had two equations, PRD or PRB, and then they were exactly the same equation, except here you take the size factor with respect to the D dimension, here you take the size factor with respect to the B dimension, and that's the only difference. And so we can clear that. So this is what I'm going to do. So here's the equation. I didn't write, yeah, I put PRD, and here's the equation, okay? Now, this here you get from the tables. Cross-sectional area, this is your size factor, and of course this is the slenderness factor, not the slenderness ratio. So we've seen this equation before. So now where do we get this? We go to table 3.1, I believe. Oh, 3.2, sorry. Okay, go to table 3.2, and we'll go to table 3.2. Now, this is table 3.2. So this is the, first of all, this is the species that we're using. This is the grade that we're using. Now, when we're doing the example way back when, we said that our load was standard, but we know that our load is not standard because we're doing formwork. We can take advantage of the fact that we are in short-term load, okay? We are not wet, we are not, okay? So in other words, short-term, and therefore, instead of using this value here, I can go and get 9.91, which is slightly stronger than 7.92 for the value of phi FC, okay? So I'm gonna take advantage of that, okay? Okay. Okay, now for a system consisting of at least, so in other words, I do have at least 3 studs in space no more than, so therefore I don't have to divide nothing. If I would have only one member, I would have to take the values in this table and divide by 1.1, which is not my case. I will have at least 3 studs in my wall, and therefore I will have this load sharing system, okay? And that means that this whole table is based on the fact that the KH of 1.1 is already built into it. And if you don't happen to have that, you have to reduce the values accordingly, okay? So there you go. So that's where I get the value of phi C from table 3.2. And therefore I have 9.1 MPa. And of course, A is simply the cross-sectional area of a 2x4, that's 38 by 89. Now, the size factor. Here's the equation for the size factor, DLD to the 0, and it has to be less than 1.3. If it happens to be over 1.3, I cannot use anything more than 1.3. I put the values in here, and I believe it came out to be 1.2, and somebody wants to check the math to make sure I didn't make a mistake, but that's the size factor, KD, and it's important that you don't make a mistake here because this KD value is also used to calculate the slenderness factor. That's the size factor. Now, this is the slenderness factor, and if you remember that this is, of course, given in table 3.3, this is, I made a typo here. This should be a D, not a B. Sorry. This is a typo here. This is a D, okay? So ignore that, and this should be B. Sorry, D, CD, not B. Just a typo. And therefore, so now where do I get the value of this? I go to table 3.3, okay? And of course, I go to table 3.3, and of course, again, the same thing. I look at what species I have. I look at what grade I have. And of course, I look at a short-term duration. So in other words, I go up to 59.1, and remember that these values are multiplied by 10 to the minus 6. In other words, don't forget to divide by a million. Okay, and of course they're unitless because this is MPa, this is MPa, these are unitless, it's just a ratio. You got 59.1, and that's where I come and get that value. Now, if you happen to not take advantage of this and use 51.4, you'll only be that much for conservative, so don't worry about it. But if you want to take advantage of the fact that you have a short-term load and you want to increase the resistance, you're allowed to do so here. So now, so that's the value of FC over E prime. Now, this I've already calculated. Okay, this should be a D. I'm sorry, I should apologize about that. So this is what I calculated before. This is the size factor and everything else. And if you remember, I told you that when you're doing this, it has to be anywhere between 0 and 1 in order for this thing to make sense. If you get anything over 1, you've made a mistake somewhere because your size, the slenderness factor cannot be bigger than 1, and it's always going to be smaller than 1, and it can be up to 1. Okay, and of course, the more slenderness it is, the closer you're going to be to 1. So if I look at the results of this answer, I end up with 0.176. Wow. So that means that I'm really losing a lot of resistance, okay, because of the fact that it's 3.6 meters long. Now I've got all my values here for the equation. I can simply put it in. Again, I apologize. I should have, these are just typos because I cut and paste and I forgot to change the subscripts here. So here you go. And all of a sudden I get 6.4 is not good. So I have to revise my spacing. Like I can, for example, increase the size of my stud, but what for? If the carpenter only has 2x4s that he's using as formwork, instead of making me space them at every 600 millimeters, okay, all I do now is make sure I can put them at a space where my PF is less than my PR value, and I can tell them at what spacing you can put the studs, and they would still work. So therefore, this is no good. So what I need to do is I know that the PF is a factor load times my tributary area. And I know that my factor load is 13.1, okay? I know this is how I calculated this, and therefore this was my tributary area. And I know that the PF value, okay, in other words, when I calculate this, okay, it has to be less than the PR value of 6.5. So therefore, now I can calculate the spacing of the stud. So that when I do the spacing of the stud, if I don't exceed that spacing, my PF value will always be less than my PR, because I cannot change the resistance of the stud. It's going to be 3.6 meters long, and it's going to be made with that piece of wood, and it's going to be that's going to be the PR value of that stud. And therefore, and now I look at it and I say, well, it's got to be less than 2.75 meters. In other words, I can space them up to a maximum of 275 millimeters. Okay. So so the maximum spacing I could put my studs would be 275 millimeters. And to be on the safe side, I would put them at every 10 inches, which is 250 millimeters or 200. And I tell the carpenter, space your studs at every 10 inches, you shouldn't have a problem. Okay. And that's how I tell him what spacing the studs should be if he's using 2x4s. If he's using 2x6s, then of course I would recalculate everything based on 2x6s, and then I tell him what the spacing of the 2x6 should be. And now I got to check my bearing. Of course, check the bearing of the studs on your mud plate and on your top plates. And if you remember, you just have your QR value at the bottom of the table here of whatever it is. I can't even see it because I got this thing in the way. Last viewed. So therefore you get your QR value here for an 89. Okay, the QR value is the same no matter what the species is. And of course I can also increase that by, you know, short term, the KD value 20.6. I have 23.3, that's greater than 13.1. Okay, and therefore I'm okay. And that's it. And then I would strongly suggest you do the assignment, because that's going to get you ready for the test. And that's it, guys. Does anybody have any questions? Like I said, there's nothing new here. It's everything that we've learned during the semester. The only thing that we've learned new today was the fact that when it comes to formwork, we need to consider the concrete as being live load. We have to also consider a walking load on the formwork, because, you know, we don't see that, but we know that eventually the workers will have to be on the formwork to place the concrete and work there. But everything else is something we've done up to now, and it's just like, other than those two new, call it modifications, and of course taking advantage of KD equal to 1.15 because it's less than 7 days. Everything else, as a matter of fact, we've talked about short term, and this is where we would actually apply it when it comes to formwork. And that's it. And I'm going to recording. How's it? So it's being recorded. Thank you, because I put everything on pause because I'm not going to have the video go on for hours. Okay, so basically, okay, when it comes to a piece of wood, okay, let's clear all this. And this way, I want you guys to see this, okay? If you see this, you'll understand it for the rest of your life. If you don't see it, you're just going to be doing it mechanically, and you're going to just, you know, forget it once the exam is done. So, and then if ever you need to do it one day because you're doing something at home and you want to know how to join two pieces of wood, you're going to say, what the hell am I doing? You won't even know how to tackle it. But basically, okay, what they're trying to make you understand here is that this is a piece of wood. Okay, that's a piece of wood. I don't care what size it is. I don't care if it's a 2x4. I don't care if it's a 2x6. I don't care if it's a 2x8. Okay, what I care about is what's the species. Okay, so the species is going to determine criteria when it comes to me putting nails. Does everybody understand that? Okay. Now, when I put a nail, let me just. When I put a nail on a piece of wood, okay. When I put a nail on a piece of wood, there's a number of things I got to look at. Okay. What I have to look at is what is the direction of the grain? Everybody understand what I'm saying?
Yeah.
Okay. Why? Because the direction of the grain has a resistance when the force is being applied parallel to it. The direction of the grain has a force when it's being applied perpendicular to it. Everybody appreciates that now? Okay. And that's why how are the forces being applied to the grain? The resistance of the wood is going to be different. Okay. And therefore, like, I'm going to do this so that you can maybe finally understand that when it comes to bearing, the forces are going across the grain, and therefore it has a different value than when it's being compressed longitudinally. Okay. But that's, like I said. Now, so when it comes to nails, okay, since the resistance of the wood, of the grain, of the wood will vary on the direction of the grain, well, when I want to put nails, okay, what they want to do is, if I decide to put a nail here, okay, if I decide to put a nail there, okay, I should have, okay, and I decide to put a nail here, and I decide to put a nail here, okay, what they're saying is that, well, when it comes to a species, well, you got to be careful. You got to be careful that you don't want the wood to split here when you put this. So therefore, if you don't want the wood to split there, you need a certain end distance. You understand? And what they did by doing tests, they've realized that when it comes to SPF, the end distance should be a minimum of 39 millimeters. So don't go less than 39, the wood might split on you. You understand why they came up with this end distance? Is that still not clear to everybody?
No, that's clear. Yeah.
Okay, now it's clearer. And then they call this the D value. I'm sorry, is it the D or B on the table? I don't remember. Is it
That's
the
B value.
The D, it's the D for the end distance, right? Okay. Now, they also notice that when you drive a nail onto wood, okay, you don't want it to split along the edges. So they have an edge distance, and that's your B value, if I'm not mistaken. Am I correct?
It's the reverse, sir.
Yeah?
Yeah, BAAB.
No. I'm talking about, let's just look at what I'm doing here. Then I want you to relate why they have these values here. I just want to make sure I'm using the right letter because I don't have the table in front of me. And does anybody have the table in front of them?
Yes, sir. It's the opposite of what you said.
It's the opposite, right?
Yeah.
So that's why. Correct me, because I don't have the table. Because if I had the table, I'd be able to see right away. Because I don't memorize these things. I go to the table and I still go look at the values. You understand? I don't memorize these things. I go to the table, and I go and I look at, what is B and what is D. But I know what B and D stand for. Okay, so here you're telling me that. So this here is D, and this here is B. Agreed? You understand?
Yeah.
So that's what these distances mean. Now, if all of a sudden I want to put two nails side by side, how much do I have to keep in between them so that I can have two rows? Well, according to the table, this is the C value, and this is 26 millimeters. Okay? Now, if I want to put two nails parallel to each other, how far apart do I have to keep them so that I can maintain, that the wood will not get, the stresses in this nail will not overlap with the stress, and that becomes your A value. So, and I think that's 52. Am I correct? Who has the tables?
Yeah, you're correct, sir. It's 52.
Okay, so I have 52 here. So what they're saying is that if I'm going to be putting nails in the same line and they're going to be parallel to each other, I cannot put them more than 52 millimeters apart so that they can have sufficient wood around them so that they can bear against the wood and the wood won't become overstressed. Okay. Now, so what we did in class, we said we have a 2x4. Okay, we have a 2x4. And we said we know we need a minimum edge distance here of 13. We agree? We need a minimum edge distance here of 13. That's the minimum. Okay. Now a 2x4 happens to be 89 millimeters. Okay. Now, can I put another nail in here in between? I don't know. I have to have a minimum C value of 26. 26. So if I have 13 plus 26 plus 26 plus 13.
78.
How many is it? 78?
Yeah.
Wow, guess what? There's enough space. Do you agree?
Oh, okay, I see.
You understand? In other words, now if I was using a 2x3, look at this, a 2x3 is 63 millimeters. Can I put 3 rows on a 2x3?
Of course. Yeah. Let me check.
No, you're telling me that you need 78 minimum.
It's 2x3. I don't know what's 2x3.
A 2x3 is 63 millimeters, 2.5 inches.
Oh, okay. No.
So can you put 2 rows?
You can put 1.
No, I can't put 3 rows. I can put 2. Do you follow? Because on 63, I can put 13, 26, and 13.
That's it. Okay.
You understand? So I can put 1 row there. I can only put 2 rows.
Okay.
Do you understand?
Yeah, I got it.
So that's what these letters are all about. Like saying, if I want to put nails in a row and it's parallel to the grain, what's the distance I have to keep between the nails in that row? And when I put nails in another row and it's perpendicular, what's the distance I have to keep here? Then if I put this row of nails here, how much do I have to keep here from the edge so it doesn't split on me? And how much do I have to keep on the end here so that it doesn't split on me? And that's what these...
And from the table, it's the minimum. Like
those are all minimum. So in other words, if you really want to, you're stuck and you don't want to, you're very congested and you don't have the space to put. So that's the minimum you can go. That's what the table means. It's the minimum. Okay.
Got it. Okay.
So it's just like, for example, what we did in steel. The minimum dimension that you have between bolt holes is the minimum is 2.7 times the bolt diameter. Does anybody ever use that? No. Unless they're really, really constrained in the space. But that, in other words, so in other words, if I have a 20 millimeter bolt, I cannot put them any closer than 54 millimeters. You understand? And the same thing, it comes with wood. In other words, I cannot put these closer than 26 millimeters. I cannot put this closer than 39 millimeters away from that edge. I cannot put these closer than 13 millimeters from that end, from that edge. That's what those dimensions are all about. And that's for SPF. And then if you had Douglas fir, you go on the other side of the table. So like here, if this is a 2x6, how many rows do you think I can put in a 2x6?
2x6, let's see.
But what advantage would I have if I'm able to put 4 rows in a 2x6? Because this is going to govern the size of the plate this way. Once I just want to keep the same number of rows this way, because I'm going to have this length is going to definitely be longer than this length, and therefore, understand? So here, the only problem here is you have to make a decision. Okay, let me clear this. Okay, so for this joint here, you do 2 things. Do you really want to become super economical? Okay, and I'm going to just draw the mitered bottom chord. Okay, there's the mitered bottom chord, and that's where the, okay, so there's the mitered bottom chord. Now, are you going to start here, putting your 3 nail with that minimum end distance there, or are you simply going to start here and start calculating? It's up to you. Like, why do you even want to waste your time in here?
That was my question before.
It's up to you. If you want to do it that way, do it that way. I'm not going to stop you.
It looks weird. Because it looks weird not having anything in the corner.
The carpenter's going to put it, but in terms of calculating this length here, won't this length here be longer than if you calculate it from there?
Yeah. because it's a smaller. It's it's 89. Sorry, it's 38 millimeters. It's not 140. So naturally, it's going to be longer because you could fit less rows.
38 millimeters. I don't understand what you mean by 38 millimeters.
Well, it's a 2x4.
Yeah. So,
89. Sorry.
okay,
yeah,
89. Okay,
89
when I said
millimeters,
38, I says, wow, we're
No,
talking about a 2x2.
Excuse me.
Not a problem. Okay. So like here, like guys, it's up to you. If you really want to get, technical and you want to put the 3 nails in this direction, and then start calculating from this length here, it's up to you. You understand? But if you want, you can start right here. If I start right here, do I maintain that minimum end distance? You better believe it. You understand?
Okay, so it's more okay.
Then, so I'm going to end up with a slightly longer gusset plate. I don't care, because whatever I specify here, I just want to make sure that when the carpenter looks at my typical nailing pattern, okay, you understand? The carpenter is probably going to stick a couple of nails in there anyways for you. You understand? But as far as you're concerned, if I calculate it from here, won't this gusset plate be longer than if the guy starts actually putting the nails here and goes all the way out there? Yes. So as long as he's got the room to do the nailing, you don't care. What you don't want to do is all of a sudden you specify here, for example, we said 2 feet 2 inches here, right? Okay. And all of a sudden on your drawing, you specified 1 foot 8 inches for the size of this gusset plate. And then the guy comes and he looks at your typical nail pattern that you had here and he says, impossible, it doesn't fit. That's what you don't want. Okay. Now, the reason why you want to have these gusset plates is that when you take your sheet of plywood, okay, some people take the trouble when they have the sheet of plywood, they decide how they're going to cut their pieces from this plywood so they can maximize the amount of waste that you're going to have at the end of the day. So that's why you want to know the size of these gusset plates. So the cut sheet will tell them, well, you can cut these 2 over here, you can cut these over there, and so on and so on. You understand? So that's another advantage of telling the guy what's the minimum size of gusset plate you're going to be using. So when he does his cut, when he lays out his cuts for his sheets, he'll try to minimize the waste of the plywood. You know how many people, like for example, especially in the furniture business where plywood, like the furniture plywood is very expensive, okay? Trust me, they take a lot of time of putting a 4 feet by 8 feet and they want the grain to go in a certain direction and need certain size of panels. Well, believe it or not, they do all of this on paper and make sure that, like they can actually get those pieces, and then they go on the table saw and they cut their wood. So this way they don't scrap too much wood, understand? The same thing with plywood, you understand? If you don't care about the waste, that's another thing. But if you want to try to minimize, if you're doing this at home and you don't want to buy 2 extra sheets of plywood because it's going to set you back an extra $60, well, the advantage of doing this, like, so if you're doing this at home and you want to save some money, I would definitely start calculating my nails from here. You understand?
So, sir, do we show the nailing placement?
You don't show the nails on the gusset plate. No, the carpenter is going to be like, you show one typical detail. You understand? In other words, nailing. Okay. You're gonna. They didn't have it here, and it's wrong. They should have one detail. Okay. For example, you just show, like here, you're gonna show 89. Okay. You're gonna show the end distance here that you want 40. You're gonna show that you want an edge distance here of 15, right? And then you're gonna show that you want to have the nails, like you just show a very small. You understand?
So we don't do it for each connection.
You don't put the nails on each gusset plate. No, you understand? The carpenter is going to be able to place the nails according to what you have here. What you want to make sure of is that these things are long enough and big enough so that the spacing that you have show here, when at the end of the day he's actually going to be able to physically put them into that, on the truss.
So it's to figure out the size of the gusset plate.
Yeah, well, the size of the gusset plate, like I said, it's just a question of like, for this one here, it was very mathematical the way we sized it, right?
Yeah.
You understand? Now, when it comes to this one here, okay, so this is what happens. Like, are you going to sort of like look at the miter joint, and you're going to start here and keep your 40 millimeters here like this, and then you're going to go off like this way? It's up to you. You understand?
Would you like to see it in our calculation sheet?
Pardon?
Would you like to see the nail placement in our calculation sheet?
Well, it's like if you want to assure yourself that it works properly, yeah, that would be nice. But if you show me how you calculated the actual gusset plate, okay, like what some people do, okay, what some people did is they took out their AutoCAD drawing, like they drew this truss, okay, and they respected, and then they just had AutoCAD do the calculation for them. And then they just made little copies of the AutoCAD drawing. They showed me how they ended up getting the gusset plate. You can do it that way too if you want. You understand? Hold on, I got a chat here. I don't know why people send me chats because I told everybody don't chat, just interrupt me. I have a chat. I completely oversaw the chat. Mouse. Sir, I sent you a Mayo. So what do you want me to do, Emil? I'll see the Mayo after. Okay. Okay, so guys, like I said, do you want to use AutoCAD to calculate your gusset plates?
I get maybe it would be, yeah. I'll try it out. I'll see.
It's like, guys, like I'm just trying to make you understand it. If you're looking at things, you know, if you want to try to do it analytically, that's one way. If you want, like, once you've drawn this truss here, you understand, on AutoCAD, right? Simply take this, copy this here, okay, and then keep the 40. Like, in other words, place your nails according to the dimensions you have there. You understand? And I mean, that's going to be very quick to do with AutoCAD. I mean, I can open up AutoCAD and we can do it together if you want to do one with AutoCAD. It's up to you guys. Like, guys, I'm here to help you. I'm not here to hinder you. You understand? If you want,
I don't mind that.
You don't
Yeah,
mind
me
that?
too.
Okay. So like I'd have to go and open up AutoCAD. That's going to take a while because I got a very slow computer. So I'm going to have to stop share. Gordon, you're going to have to. Well, first of all, before we leave this, does anybody have any questions on this drawing?
I calculated some of the gusset plates for most of them. If I tell you, would you be able to say if they're
No, I don't know, Gordon. Like
Okay.
I don't know. Like these were last year's values and this year's values. I don't know. You understand?
Yeah.
I haven't done it. Like I haven't done it yet. I will be doing it before the end of the semester, but I haven't done it yet. So, you understand?
I'll stop share.
Okay, so like I'm not going to I'm gonna have to hold on a second. I'm gonna have to open up AutoCAD. Oops, sorry, cancel. Where are we? Minimize this. Yeah, so I gotta remember to send you guys a lecture and the video, right? Send lecture. I have to write it down, otherwise lecture and video. Okay. So let me just close this. Let me go see if I can open up my AutoCAD. There you are. Oh, wait a second. Do you remember what lab I'm gonna go open up the AutoCAD drawing right now. Do you guys remember what lab I talked about the drawings? No,
Sir, it was lab 5.
lab 5. Okay,
On
so
lab 5, you provided the documents.
okay, so I'm gonna go open it. I'm gonna open up the typical drawing right away. So this way, it's gonna take a while, but it's gonna open up lab number 5.
Sir, the wood exam is next week, right?
Sorry?
Wood exam is next week.
No,
We covered this. It's in 2 weeks.
we've already gone through this. Don't bring it up again because we had the poll and it's the week 14. One person said week 14. It's gonna have to be week 14. You understand?
Well, next week is week 14, no?
Just
Next week,
for the record,
next
it was
week is
easy.
week 13.
13.
Okay. We have 3 more weeks as of tomorrow. When you finish your classes, whoever has Sophia Barbaroussi tomorrow, that's it. You've completed 12 weeks of the semester. You've completed 3/4 of the semester. You understand?
The whole time I thought we were week 13 already. All right, my bad.
No, like we are in week 13. We are in week 12 right now, and we're just finishing off week 12.
Oh, okay, perfect.
Okay. Hold on a second. I'm not sure if I'm opening up the right. I'm not sure if I'm opening up the wood. I hope if I'm not opening up the right one, I'm going to open up the other one. But with project, I'm going to need the project itself to be able to draw the truss. Okay, so I hope you guys are opening up AutoCAD too, so you can do this at the same time simultaneously. I don't know if those of you that have AutoCAD, but I don't know. So this is taking long, but like I said, do you guys, I'm sorry, do you guys remember what I called the name of the file when I sent you? Did I call it wood template or did I call it wood 2021? I don't.
Yeah, template. Okay,
so I'm opening up the wrong one. So anyways, once AutoCAD is open, I can open up any file I want. So this is taking very long. I should have paused the recording too, and this way we can all see this together. Okay, where are we? Share screen. Okay, so I'm just gonna go to AutoCAD because I won't have to go anywhere else. Share. So does everybody see AutoCAD?
Yeah.
Yes, sir.
I remember I showed you how to put in the foundation walls and then copy the floor plan. That you've done, right? Because I don't have that here.
Yeah, we did that.
Okay, so like right now what I'm going to do is, of course, like if I was doing the third drawing, I would say copy, you understand, copy, and then I would, of course, you know, and copy selection, specify base point, there you go. And then after that, I would just copy this and then, and then of course I would start my drawing up here, right? Okay, and this would be S3 or 4, because this would be or is this 4 or 4? This is 4 or 4, so therefore this. Okay, so now, guys, very quickly, we'll draw the truss, okay? We'll draw the truss, and of course, the truss measures 27 feet 9 inches, right? So we draw, well, first of all, make sure I draw a line. Okay, let me erase this, get rid of this. Okay, so we're going to draw a line from there to 27 feet, 27.75 feet. So that's the length of the bottom chord. We agree? So far, so good?
Yes, sir.
Yes.
Okay. Now, I'm going to draw a line from this point here, okay? And the slope is 6 and 12. Agreed? So it's moving along the x direction by, let's say, 6 and 12, that would be what? 48, comma, 24. And there is a slope of the roof. You see it? Right? So once I get do you understand how I got my angle?
Would you do that? Just say it again. Just 1 second.
I'm going to erase it. If you look at, if you don't have the diagrams of if you don't have the diagram of the truss in front of you, you won't understand. Like for example, the slope of the roof, for every 12 units I go one way, I got to go up 6.
Okay.
Do you understand?
Yep.
Okay. So what I did here, Omar, is I said, draw a line from this point. So I went over 48 this way. That means I got to go 24 up. And that's going to give me the angle of that roof.
Okay.
Does that make sense?
Makes sense.
Now, once I get that angle, right, what I'm going to do is I'm going to let AutoCAD do the rest. I'm going to say mirror. There's my mirror command. I'm going to mirror this line here. I take this midpoint here and I'm going to mirror it there. And then once I have that, oops, sorry, I do that again. Mirror this, okay, find my midpoint here. Go down, enter. Now, if I want these two lines to join together, I simply say fillet, camber this line with this line, and there's my truss, okay? Now, if I want to make sure I can extend this, right? I know I draw a line this way. This is just to, okay. And then I can do it. I'll do this anyway. Then I say offset. Like I don't do any. I let AutoCAD do all the offset 1.5 feet. Okay, and I offset this line here. And then after that, I simply chamfer this line with that line, and there's the length of that overhang. And of course, okay. And then if I was really lazy, I would erase this. And I would mirror this. And there, now I've got, okay. Now, erase. Now, there is basically, okay, now, what, are you going to take this as being the center line of your lumber, or are you going to be taking this to be the edge of one of your lumbers? What do you want to do?
The edge.
The edge, okay? So you want to take this to be the edge? Like, it won't make a difference, trust me. But if, in theory, this should be the center line of your lumber, okay? So in other words, okay, so this is the edge, okay? So therefore, what I'm going to do is I'm going to say offset, okay? Now, a 2x6 is 5.5 inches. Okay, so there's a top chord, okay? And a 2x4 is 3.5 inches. Sorry. So offset 3.5. And there's a bottom chord, okay? Now, if you want to complete it, okay? Now you can either miter this vertically or you can have it like that. It's up to you. It makes no difference, okay? And of course, do the same thing on this side. And of course, we can extend. And like I said, I have the newer version, so I don't have to go and pick my boundaries, but you just extend that line, okay? And of course, I can chamfer this. And because there's a joint there, I'm going to draw a line. Fair enough? Now, what I should have done, if I was smart, okay, before I did all of this, I should have found my midpoint here and brought it down to here. So therefore, I wouldn't have to do any calculations, you understand? So now for me to do that, okay, I'm going to have to go back, and now I should have thought of that first, and therefore I should go ahead and I should break this line. So there is broken there. And if you see this becomes one line, okay? And of course, this is in 3 points, so I say divide. Divide. I select this, and I divide into 3 segments, and AutoCAD divided that in 3 segments. And if you notice here, now you're gonna have an endpoint somewhere around here. You're gonna have a node.
It's about 9.3 inches.
Okay, there's my node, and then I'm gonna have to go to midpoint here. Okay. Like I said, for my graphics card is very, you understand? So I should have gone and find my, okay. But anyway, I'm just gonna draw this like this. Sorry guys, like I said, my graphics card is very, very weak. And so I'm gonna go find that midpoint line. from that midpoint. Where's that midpoint? There's my midpoint.
So you have your snap on the straight line.
I have my snaps on.
The ortho.
Oh, I have my ortho on. That's why it's becoming such a pain, right? Anyways, guys, I gotta go find that. Sorry. I should have, like I said, my graphics card is really weak and I should not be doing this with this old computer, but I probably have my O snaps on. Is that what's happening?
If you press F8, it will disable the ortho.
Okay, but at the same time, I think this is, I want to make sure I don't have my O snaps on because I won't be able to snap to that endpoint. Okay, did I take that off? Yeah, it's all off. Like I said, anyways, guys, like I apologize, my graphics card is really outdated and I need to draw a line from here. Anyways, like I said, so well, all I'm trying to show you here is that if I had a better graphics card, and because AutoCAD is becoming more, like I probably don't even have enough RAM for the amount of, you understand? It was escape. So you're getting the gist of it, but this is, I'm just trying to show you how quickly you can draw this truss, you understand? If I would be able to line. Like, what I'm trying to show you is that how you use AutoCAD to do all the calculations for you instead of you having to do any calculations. I still can't find that stupid midpoint. I know it's around here somewhere. Or I should just do this. D-I-V-I-D-E, divide, enter, select this, and divide it in 2. There you go. So now I should be able to find that node somewhere around here. Oh, wait a second. I probably, where's my O snaps? Yeah, I see. They're all on. Select all. Okay. Cancel. There it is. There. Finally. Okay. So that, and of course, I'm going to erase this. Okay. Now, if you want, okay, and if you want to make that halfway, then you offset this 1 3/4 inch, 1 3/4. That would be 3.5 inches. Okay. But before I do that, I'm going to add one more member from here. There you go. Okay, so like I said, so you offset 1.75. That's that. That's that. That's that. That's that. Okay. And then of course you can come in here and clean this up a bit. Okay. If you want. Okay, so you trim. Excuse me. Trim. That goes. Okay. Like I should have. And of course, do the same thing up here. Clean this up a bit. Okay. So I have to trim. And I have to, oops, sorry. I have to extend. Anyways, you guys understand what we're doing, right? We're just cleaning up our drawing a bit. I'm sorry, that's the one I want to extend. And of course, once I clean that, just to show that this is a miter joint, I would draw a line from there. Well, I hate this fact. Okay. I have these menus in the way here, sorry. Okay, so delete, there you go, line from there. Okay, so there's my miter joint. Anyway, once I've cleaned this up, I would just mirror it and it will go on the other. As a matter of fact, when you do your gusset plate, just work on this half of your truss. And then once you put in all your gusset plates, you just mirror everything at one time, understand? But right now, let's go here. So for example, I'm gonna copy this because this is gonna be the right proportion. I'm gonna erase, let me erase these lines here. Okay. And so I'm going to copy this just for the hell of it so we can work on it separately, or I can do it right here and then you guys can decide what you want to do with it, okay? So we know, like for example, we know that we need an edge distance of 40 millimeters. So with AutoCAD, you simply say offset 40, okay? And that would be the end distance from there. Sorry, the offset. I did 40 millimeters. Sorry, I have to do this in millimeters now. So 40, it's true. We're doing everything in millimeters. 40 divided by 25.4. So it's 1.574 inches. So offset 1.574. And so that's where that row would go. Okay, I should have done that. So that's where the nails would go. And we know that in this direction here, we said 15 divided by 25.4, that's 0.59 inches. So we say offset 0.59, okay, from there. So that's going to be another row. Those are the two outside rows for the nails, right? And after that, what we need to do is, of course, put a line right in between. So we're going to draw a line from here to here, perpendicular, and we are going to offset through. We're going to go through a point, okay, select object, and then go find that midpoint, and there you go. And that's where the middle row would be, okay? So you put a 0 there, an X there, and a 0 there, okay? Now, you know that the perpendicular distance, okay, between the rows have to be at least 60 millimeters, right? So you would say, so what's 60? Did we say 60? Yes, 60 divided by 25.4. So that's 2.36. So we say offset 2.362, okay? And that would be where the next row would be, okay? And of course you would extend it. Okay, we would say bound, okay.
Sir?
Yes.
The 25.4, is that a number of the nails?
No, every inch has 25.4 millimeters. You don't know how to convert inches to millimeters?
Sorry, because I was looking at,
okay. Boundary. I'll take this boundary here. Okay. Okay, so in other words, here you have 3 and 2, that's 5. Okay, so in other words, then you just keep on offsetting until you have the number of nails, and then you let AutoCAD calculate the distance from there to there with the edge distance. Is that clear to everybody how to do it? If you want to do it that way. If you want to start here, right? If you want to start here, then you know that if you want to maintain that 40 millimeter distance here, the edge distance from there to there, which is 40 millimeters, right? Sorry. You need to make, if you want to run them parallel this way, okay? And if you don't want to run them parallel, is everybody confused on what I just did, or is it clear? Like if you measure the distance here, is
Yeah, I'm a
everybody
little confused, sir.
you're a little confused? Like, yeah, that's why I don't like to do things at diagonally, because you guys have problems seeing it when it's perpendicular. But I thought you said you guys wanted to put nails in here. Do you remember, like, for example, here, let me just, because I have all these menus in my way, guys, and I can't get to my menu, okay? There we go. Measure distance. What do we say that was the A dimension?
52 on the.
No, 60. 52 is the
yeah,
minimum. Stop, you know, my God. Okay, so.
Just making sure.
Okay, so in other words, 60, right? Should be the distance there, right? Agreed?
Agree.
Okay, so 60 divided by 25.4. If we were doing this in metric, we wouldn't have to do this conversion, but it's 60 divided by 25.4. That's 2.36 inches, okay? So erase. Okay, erase. This is wrong. Okay, so. Okay, so right here, I'm going to extend this line. I'm going to show you, okay, I'm going to show you, like, if you want to do it accurately on AutoCAD, I'm going to do one here, and then you guys are going to be able to do it all over. So let me extend. Okay. Now, let me draw a line here. Okay, here's a line. Let me put my ortho on. Okay, here's my line. Now, we know that the distance from the edge to the first nail has to be 40 millimeters. Okay, 40 divided by 25.4, that's 1.57. So I say offset 1.57, and of course by default it's inches. And that's where the first line of row should be. Okay, so I'm going to move. That's where my first line of row should be. Okay. Now, after that, I know that I have 60 divided by 25.4. I have 2.362. So I say offset 2.362. That's 60 millimeters. So there's from there to there. And that's where the second row is going to be. So that's 60 millimeters right there. So I'm going to move this. Oh, I'm going to move this. So, okay, so in terms of nails, right? Like this gives me 60 millimeters difference. This is my C distance. This is my edge distance. This is my edge distance. Okay, and then this is my C distance. So that's my pattern right now. And I know that in this pattern, I'm going to have 3 nails here. I'm going to have 2 nails in between and 3 nails there. Does everybody see that? Or do I need to draw that in?
I see it.
Pardon?
I see it.
You see it, right?
Yeah.
Okay. Okay, so how many nails, how many times do we have to repeat the pattern of 5? How many nails, first of all, do you have in this thing?
Oh, in the first joint.
Well, you tell me how many nails you have in this joint.
36.
36.
30, is that it?
36.
36.
Okay, you have 36 nails, but we're starting with 3 at the beginning. Minus 3, that means we need 33. And if we have 5 nails at every pattern divided by 5, right?
Yeah, we need to do it 7 times.
7 times. So look, this is what you do. You say copy, okay? Copy this, right? Fair enough. This is your base point here. And you're going there. And you're going there. That's twice. That's 3 times. That's 4 times. That's 5 times. That's 6 times. That's 7 times. And there's your last nail. Isn't that simple?
Way easier than on paper.
Pardon?
I mean, it's way easier than on paper.
Exactly,
because,
exactly. But that's if you want to put them diagonally. If you're putting them perpendicular.
That's how I did this one, actually.
Okay,
Exactly like
now
that.
there's only one last thing you have to do is that you realize you need an edge distance from here to here, right? So in other words,
of 40.
So well, we have
minimum.
to do it in inches. So therefore, 40 divided by 25.4, that gives me 1.57 again. Okay, so I'm going to say offset 1.57 again, and that's where my gusset plate is going to, in theory, end. Okay, so therefore, if I extend this, okay, so in other words, I'm gonna extend it. I'm not gonna. I would have like that's why I wanted to copy it. I was just gonna chamfer and see what the distance was. You understand? But I'm gonna extend it. I'm gonna say boundary. This is gonna be the boundary. Enter and extend. So what's the size of your gusset plate? Well, you measure from. You measure the distance from here to there. So you have so you're going to make your gusset plate 2 feet 4 inches long. How's that? Because it's 2 feet 3 7/8. You're not going to specify 2 feet 3 7/8. You're going to make it 2 feet 4 inches long.
Understood. Yeah.
Okay. So in other words, so what you do is you take a line, you draw a line. In other words, you draw a line. Line. Sorry. You draw a line, you start here, you go up like this, okay, and then you say offset 2 feet 4 inches, and then you offset it from here to there, and there's your gusset plate. And then you extend it up here, and there's a gusset plate for that joint.
So I have a quick question.
Yeah.
I calculated my size of gusset plate by hand, and then I got like 1,000 millimeters, which is
1,000, which is like it's very close because 3 feet 4 inches. Yeah, well, 3 feet 4 inches is 1,000 millimeters, isn't it?
Yeah, it's like 3 inches, and then it's 3 feet something.
Well, you said you had 1,000 millimeters, so that's like 1,000 millimeters is three. It's almost like 3 feet 3 inches. You understand?
Yeah. Okay, so it's good, right?
Yeah. No, you don't have to redo it. You understand? See, like I'm not looking here. I'm not looking for 3 feet 3 7/8. You understand? I'm looking for something in the order of 3 feet 4 inches, 3 feet 3 inches. You understand? It all depends. But you understand, like, and that's by AutoCAD. I know that that's going to work perfectly now. Okay. So since I don't need all these you understand? Since I don't need all these other lines, I simply go erase. Of course, get rid of those things. You understand? I don't need any of these lines. So and then I would copy this. Okay, because I want to copy this to start off with, so this way I could have just trimmed this and already done my detail for gusset number 1. You understand? So guys, use the tools that you have to simplify your life. Do the same thing on this side here. When you calculate a number of nails, for example, you know that, for example, it all depends where you want to start in terms of your edge distance. You want to start right here. What for? Like you draw a line. Okay, start from here. Draw it perpendicular. Just draw perpendicular. I'm trying to find there, perpendicular to there. Okay. Just see, like, you have to make sure that you have an, like, in other words, like, for example, this is again, like you offset, you understand? And where this line intersects, you draw a line, you offset it perpendicular by 40 millimeters, whatever it was. And then after that, you start your nail patterns always like this. And then you decide how far you need to go. And that's going to be the end of your gusset plate. And then you're going to be able to do maybe the same thing on the other side because it's okay. And then from there, you'll be able to say, oh, here's my gusset plate. Like it stops here. Some people like to draw it. So, I mean, we can do this one also, but you can use AutoCAD to do all these calculations. I would use AutoCAD. That's how fast it is, you know. But if you know how to use AutoCAD efficiently, it's really quick. Did you find that this took long to calculate this gusset plate?
No.
And the thing is that you know that it's accurate. You understand? If you follow, so and you know that it's accurate. So there you go. Okay. Hey guys, it's already 5:36. It's up to you. We can go up to 7 o'clock. No, 6:30. It's up to you. So guys, like I said, like why is this like it's not it's like it's to me AutoCAD is a great tool. Okay, it's a great tool. It helps me do a lot of things without me having to do any trig. But as long as I know how to, you know, execute the commands with AutoCAD. Okay. You guys want to hear something interesting?
Yeah, go ahead.
Okay. I have a sailboat in Florida, okay? And in order for me to get to where I want to sail, I have to go underneath a bridge, and unfortunately, I have to step down my mast, okay?
Yeah.
So, and I want to be able to calculate, for example, I'm gonna draw it. This you guys are gonna, you know, like annotate. Okay, I'm gonna draw this. Okay, I'm gonna first of all let me stop recording this because we don't need to record this. But where's the options? The options. Stop sharing. I'm gonna put this on pause.